Hey guys, welcome back. Today we are upgrading our Monport K40 so that we can use Lightburn. Don't forget to like and subscribe, guys, and comment down below any thoughts you have. We are using this new Monport motherboard that Monport just released. It's right around $150, but you know, use our code on the Monport site, KLR form, and it'll get you a 6% discount. So this is just going to convert our K40 so that we can use Lightburn instead of the K40 Whisper.
All right, before you start anything, make sure and unplug the laser. This does have enough power to hurt you. So unplug that from the wall, first thing. All right, so in the box, we have new control module, a new USB cable, and I believe, yes, this is USB-A to USB-C. So we'll see if that's long enough. And then we've got power cable for plugging into the board, and some connections, bolts, everything. We'll figure that out. And that's it. No instructions. All right, so I'm going to check out the website, see if there's any instructions there, and then we'll figure out what to do. Okay, so there is a manual on Monport's website under this board. However, it just tells you what the ports are on each part. It doesn't actually tell you how to do this conversion. So let's get in and take a look at the other board and then see what we need to do. First, definitely going to unplug everywhere. All right, power is unplugged, ports unplugged, and we can start to kind of look in here. So we've got, it looks like only 4 ports are plugged in, and then just the standoffs, and it looks like this whole panel can come out with just 3 nuts. So let's take this whole panel out and get a better look at it. That had 3 nuts and bolts on them, all 10 millimeter. So we got those out, and now we can start to move this. Now we're not going to have enough room. Okay. So we've got the, let's take these off. We'll try and remember which one's which. So here's which one's which. X-axis, Y-axis. So there's nothing clearly telling us on that. I'm going to grab a little Sharpie and mark it. This one is X. And then this one is Y. Alright, now we've got which one is which. Alright, these are the other 2 that were plugged in. They're vastly different, so we'll take a look at what we got. Alright, here is the new board. We've got our USB there, our power there, so we're going to install it this way. Looks like it is not going to line up with anything, so we'll have to figure that out. So let's get this board off first. So since we started this project, Monport actually put out a little bit better of an instruction video. So I know what we're doing, and now we're going to be able to actually put it in. One of the first things we need to do before we dig in, though, is on the limit switches. They need to be changed from normally closed and confirm that they're both on normally open. So it's a little bit, okay, so it's a little bit hard to see, but you're going to have 3 pins. One's going to be NO, one's NC, and then you've got your ground. So we want to make sure that it's on the ground and NO, so normally open. I'm going to get those changed. So one thing we have to do is actually flip the limit switches. On here, you can see there's a C, an NO, and an NC. And the directions say that these need to both be NO. That means normally open, and when you click it, it would close. Right now it's normally closed, and when you click it, it opens it. So we've got to flip those, and they are soldered on both of them. So I've got soldering iron, and I'm going to get the other side soldered on. Okay, so they didn't give us a lot of extra wire or anything, so I'm going to do this with the help of Aaron as a third hand. I'm just going to tin this one a bit, and then I will swap the wires. Alright, now I'm going to just heat up the old one and pull the wire off of it. Just like that. And then we will use the solder that we put on the new side and just get the new wire on it, or get the wire on it again. Alright, and now we've got it swapped the way we need it. And just slide back on the cover. Alright, we can get that put in place and we'll get the other one done also. Alright, so this is just a multimeter. This one can do a lot of things. All we're using is continuity, so we want to hear that sound when we click the button. Alright, so when she clicks it, you can hear the continuity connect, and that goes through, so our soldering's good on that one. Let's test the other one also. See? Awesome. Alright, both of those are good, so we're going to reinstall them and move on to the next part. Alright, so the other thing you have to do is you have to remove this Molex clip that the limit switches are in, and go down to these 3 pin connectors, and you'll have one for X and one for Y. So you've got your common, and then you've got your X. This one is Y. I'm going to take apart, and then we are going to put them into these. The Y will just be in one by itself, and then the 2 other ones will be together in the other one. And this, you can either have a tool, specific tool to release these. It's got a little metal pin that flips out when you push it through that holds it from going in. I just grabbed the absolute smallest little Allen that I have. It's a 0.9, and what I've done that worked is that I pushed in here and popped that in, and then you're just able to pull it right out, and then we can get it into the new connectors. Alright, so the pins, we need to just figure out which way they face. It's going to face this way. So with this one, the common goes in the middle, and our normally open side is going to go on the first one. And then when we put the Y in, normally opens in the first one. So we're going to pop those in. We just want to make sure and get the right orientation, or you will be taking it apart and doing it again. So I'm just going to do the Y one first. It goes in, so the first one, but when I flip it over, it's the far side. And we can just pop it into place. Alright, that's the first one, and then we will get the second one also. Again, figuring out the orientation before I put these in. So those are all the changes we have to make, and now we should start plugging everything in. What we're going to do is down here on the actual power supply, we unplug these first ones. This is the actual power to the module. That's going to be left unplugged on both sides. This is also where the LED lights are in, so I'm going to have to figure out removing that and getting it into the new board. The cable that it came with is this one that goes here. That plugs into the board, and then this is what unplugs from this side, and this is the actual controller. Right, so we're going to lose where we control the power and everything on the top, on the front of the K40, and we're going to control it all in Lightburn. So this goes in to that second plug. Right, and you can see that these white wires come up to right here to this little control module, and that's just the laser percentage, and let's show it. So when you unplug that, you're going to lose this, so you're not going to adjust the laser percentage here anymore. You can't do the test or that stuff. It's all going to be controlled through Lightburn. Alright, for now, while we test it and make sure everything works, I'm not going to mount this to the plate yet. We're just going to sit it in here. So first thing is the power. Working a little bit with short cables so you can't pull it out too much, but I marked earlier our X and our Y motors. So we can get those plugged in here on the top. You can see where it's X motor, Y1, Y2, X, Z. We're only doing X and Y1. So clip those in. And then we've got our limit switches. This is going to be X plus and Y plus. So we'll get those in. X plus. Not easy to do. So Y plus snaps in, and X plus. Alright, laser control is going to go in the second from the bottom. It's there's only 2 3-pins here, and then the rest are 2 pins. So we're going in the second 3-pin. Alright, and this is how the board will look when everything is plugged in. Now we're going to plug it back in to the power, make sure the laser comes on, and then we'll get Lightburn plugged in. Alright, we've got everything back in place, modules plugged in. We're going to plug it into power and see if it comes on. It's not going to home anymore until we actually get it into Lightburn, but power's on there, and power is on the board. The cable that came with it's not long enough for our situation, so we ordered a longer one, a 10-foot. We'll get that plugged in, and then we'll jump on the computer, make sure everything connects. Alright, just wanted to note real quick, as soon as we plugged in the USB-C, light came on right beside it, so it does look like it's getting a connection, and we can check on the computer. Alright, so Lightburn. Pretty easy. You can come in here to devices, and you can say find my laser. Next. So scans for device, it finds it. This is what it's auto set to within the board. You can add. Now here you can name it. Let's see. So we will name it Monport K40. You can change the access links right here. We're not going to do any of that yet, so we're just going to leave it the way it is. We hit next. Here's where you set your origin, and this is going to be where the home's at, so where our limit switches are. And our limit switches are rear right. Or sorry, our homing switches are rear left. So we are going to click on that one, and then we can hit next. This is everything we want, so we can hit finish. We can hit OK. And now we come down here. This is the part. So all the other lasers I've had in here are labeled Gerbil, but we want Monport K40 device. COM3 is the port that it's on, and now we wait to see it connected. There we go. So when it does connect, it's going to say homing, okay, and then it comes in here, it tells you what's connected and the Gerbil version. So that's everything we want to see. We know it's connected, and now we can go back to the laser. Now this is where we ran into a ton of issues, and it's taken us a few weeks to get them all ironed out. First part is the laser was always coming to the bottom when it was trying to home. So this one worked, it went to this side, to the left, but it always came to the bottom, it would never go to the top. The first fix on that was actually changing which motor port for the Y. we changed it into the next one, and it seemed to fix everything, and it started going the right direction. So that was awesome. Then it would home and do all of that correctly. Then started to try and laser, and it just would never fire the laser, or it would always fire the laser. And that took the longest part, and talking to Monport and everything on that. Took quite a while with support to get to where I ended up just started messing with the cables and figured it out. So this is the control cable that comes with the laser, and it had 3 on one side and 2 on the other side, and none of the pins were in the right spots. So on the power supply, you've got a ground and an in. So the in is the actual control. Okay, so the in is PWM control, and what that does is that it's got a max voltage. It's kind of hard to see in there, but it's got a max voltage of 5 volts that it sends in, and as it goes up and down from 0 to 5, that's what tells the laser how hard or what percentage to fire at. And it wasn't plugged into the right spots as far as the pin goes. So the black one on this side is now the PWM, but before it wasn't. It was 5 volt and PWM, but there was no ground. And then on this side there were 3 plugged in and they weren't lined up. I ended up having to pull all the pins out the same way I did with the limit switches and switch them to get them right. And then what I found is that I was testing at 10% out of Lightburn, and that was never enough to actually fire the laser. So I ended up going up in percentage, and it started working. So that was a ton of troubleshooting with a bunch of different issues with it, but we got it working. Now here are some of the tests that we were running when it would fire and never stop firing. So it looked good on the percentages that it was running, but it would never actually shut off. So I knew that it wasn't firing correctly. Did a bunch of testing on that to try to get it right, and then finally did on this one. But then it wasn't burning the ends. So this is the first time we actually got it to fire and actually look correct. So what it did though is it like the writing doesn't come through, and some of these don't come through, and then it's not a full box. And the problem with that is back in Lightburn. The issue with this is that PWM again. So it's not changing the voltage fast enough for how fast the laser's moving. So I needed to slow the laser down or turn up the power in that. So if it's moving too fast, it won't be able to change the voltage of the laser fast enough. That might be an issue with the board. It might be an issue with the power supply. I'm not 100% sure. But I was able to compensate and get different settings. Now, if you're never changing the percentage of what you burn in Lightburn, you can actually turn on a constant power, so it burns a lot cleaner with that. However, if you turn on constant power and try to grayscale, it's going to always burn through. So it's not going to work in that situation. So there's going to be a limit to how fast you can move it with different percentages of power. That's what I found and ran into. So then we did a final test on a picture that we had done before, and this is at 65%, and it came out amazing. This is completely unfinished wood, and it looks incredible. So this is the exact same picture that we did without Lightburn, and you can tell there's not near as much depth. The percentage wasn't as high either, but with Lightburn, what's capable is that you've got a whole lot more grayscaling ability than you do with K40 Whisperer. So you're going to get more depth in it. You're going to get more gradients from dark to light, as opposed to this one that only has, 3 or 4 different shades in it. So this is the one that we originally did with borax, and it's okay. I mean, I thought it looked great until I did it again with Lightburn, and Lightburn's just far superior on any kind of pictures. The depth and clarity that you get is always going to be way better. So one last problem that we did run into because of how the limits were going, it was bouncing off the rails, and it actually pushed the air assist piece down enough that the laser was hitting it, so it melted it. Between having the laser constantly on, because it was always being fed 5 volt, and just weird control stuff, it messed this up completely. So probably have to print a new one, and or just go ahead and buy a metal one so that doesn't happen again. So the last thing that I wanted to touch on was the lighting that's in here. It was plugged straight into the power supply via this. So what I did is I cut those off. I wired those straight into a 24 volt. There's plenty of different power voltages on this board that you can get accessories plugged in here if need be. So I went with the lighting there, and I've moved them a bunch inside it because they fall or they don't light very well, and I plan on running a bigger strip so that we can get full lighting around it and actually be able to see what we're doing, just because this isn't adequate for what I think. I think we need to run lighting all the way around. Right now it's up here and it's a little bit better, but we can't see it all. The other problem that I have is how far the limits are actually moving it when you home. Let me home the machine. So as you can see, we're losing a lot of usable space because of how far it's homing out. We could have it clear over here and then clear back here and come from this corner as opposed to it bringing it clear out here. So we're losing space on that, and I'm going to have to figure out the limit switches within Lightburn to add extra usable space. But if you guys have any hints on that, that would be great. Let me know in the comments because I would like to use that extra, goodness, inch or two each way. It'd be a much better usage of the space that we have as opposed to only having a 200 by 300 millimeter usable space.
All right, keep in mind that support is across the ocean.
Yep.
Different time zone,
Yep.
different language. So there was a little bit of trouble with us understanding each other.
Yeah, and time-wise,
and
right?
time-wise, right. We're going to bed and they're up. So there was always a little bit of a struggle with that. But in the end, they did manage to...
Yeah, I mean, they tried to help. I ended up figuring out the problem.
Yeah.
But they did. They attempted to help.
They did, and they really wanted to help.
Yep, absolutely.
They were trying. So.
Yep. But I mean, that's part of why it took so long. And then it just ended up being.
Yes.
Pinning out came wrong from the factory, and it happens.
It happens.
Multimeter is what I used to figure it out. Lots of multimetering, watching pins, watching the signals to figure out what the problem was. But yeah, got it going, and we're excited to have Lightburn.
Yes,
Yeah.
very excited.
Very excited.
Don't forget, you can use our code for this.
Absolutely.
As well.
KLR form.
On Monport.
Yep.
To get that discount. So, and we're totally happy to explain anything you have questions about.
Yeah, if you have questions about any of the wiring or
anything,
how it works, or
anything that we've done
Right.
and how to figure out, just let us know.
Yep.
Hit us
Or
up.
if you have any recommendations on
Yes.
maybe how to get Lightburn limit switches, I need help with that. I'm not 100% on the code where to fix that, but yeah, if you know, let me know. That'd be awesome.
Yep. But thanks for watching, and we'll see you next time.